Hi, my name is Saif Khalil Mohammed. I am a student in Altenbash University studying master degree program in electrical and computer engineering. My student ID is 213720763. I'll talk about my project. It's on using Hamilton path problem to find a route to multiple destinations. These are the contents of the presentation. The first one is the aim of the project. The second, applications of Hamilton path and what is a Hamilton path, how to represent a graphing computer, and what is a dynamic programming. The last one is the results I've obtained after completing these projects. The aim of the project is to find the shortest route to travel to multiple cities in Turkey. It is supposed that we have 27 cities or towns located in different directions in Turkey. The mission is to travel to all of them. This is a screenshot of Google Maps tool. The tool allows us to determine a maximum of 10 destinations, but as indicated, an arbitrary complete route after modifying it. This will be done by using Hamilton path, of course. Hamilton path might be applied in some fields like designing electronic circuits. You know, electronic circuits have high complexity, consists of too many electronic components. They have to put all of them in as small place as possible. They have to design printed circuit boards and so on. The second example is determining the shortest route. You know, the shortest route is the aim of this project. Another example is in social networks like LinkedIn and Facebook. What is a Hamilton path? Before we know a Hamilton path, we have to know what is a graph. A graph in mathematics consists of vertices. These are the green solid circles, and a graph also consists of edges. That these lines that connects every two neighbor vertices that we have labeled alphabetically A, B, C, D, and so on to I. So what is a Hamilton path? It's a path through a graph that goes through every vertex once and only once. So look at the graph here. It's a random graph just for explanation. If I need a Hamilton path in this graph, I need to make sure that it goes through every single one of these vertices, and it can only go through the vertices once. So for some reason I go to C, and I can't ever come back to C again. Once I'm going to H, I can't ever come back to edge again. And it doesn't matter which edges you go through, there is no counting whether or not we have even or odd degree vertices. All we need is a path that goes through each one of these vertices once and only once. So I'm going to start in A. I'm going to go to I, then H, go to B, C, D, E, F, G, like this. You see the starting point here is A. Here is a graph that contains all the cities. We have 27 cities or towns. Istanbul is the starting point. We have to find the shortest route from the starting point to the final destination. We only know the starting point is Istanbul, as I indicated here. There is too many destination. We can go the next. representing a graph in computer. There are two ways to represent a graph in computer here. The first one is adjacency matrix. Adjacency matrix is a square matrix, consists of columns and rows. Is of size n by n, where n is the number of vertices. Like in this example graph, it's simple graph consists of 5 vertices labeled 1, 2, 3, 4, and 5. To create the matrix, we have to look at the vertices. Begins with the first one. One vertex is connected to 2 vertices, which are vertex 2 and vertex 4. So we put 1 under these columns, column 2 and column 4. All of the columns we put zeros. Next we go to the next row, the 2 row. Row 2 represents vertex 2. Vertex 2 is connected to 1, 4, 5, and 3. And all of that, all of this column contains 1. Only column 2 contains 0. And so on. Vertex 3 is connected to 2 vertices, which are vertex 2 and vertex 5. We put 1 under each columns, and other column contains 0, and so on. Notice that the diagonal of this matrix have all ones, because there is no edge connected between 1 and itself, or 2 and itself, like this. The second way to represent a graph is adjacency list. Back to the same graph, we have to sketch this diagram like a triangle. Vertex 1 is converted to this square, 2, 3, 4, and 5, and so on. Vertex 1 is connected to vertex 2 and vertex 4, like this. Vertex 2 is connected to vertex 1 and 3 and 4 and 5. Vertex 3 connected to vertex 2 and 5. Finally, vertex 5 is connected to 2, 3, and 4. 2, 3, and 4. What is a dynamic programming? It's an algorithmic paradigm that divides broader problems into smaller sub-problems and stores the result for later use, eliminating the need for any recomputation. To achieve this algorithm, we have to take into account these observations. Number 1, the idea is such that for every subset S of vertices, check whether there is a Hamiltonian path in the subset S that ends at vertex V, where V belongs to S. 2, if V has a neighbor U where U belongs to S minus element of V, therefore there exists a Hamiltonian path that ends at vertex U. Finally, the problem can be solved by generalizing the subset of vertices and the ending vertex of the Hamilton path. Now, finally, here is the result we have obtained after completing this project. On the left is a a table of the cities' names. They are ordered arbitrarily, starting from Turgutlu, Antalya, and so on. On the right is a table of the cities' names after completing the project and running the code. Now we've got a route that begins with Istanbul and ending with Sakarya. These are all the cities in this project. Thank you for watching.